I have been exploring the secrets of the TPM.
Is that anything like the TPS report from Office Space?
Almost exactly as useless. No. I jest, of course. So TPM stands for Trusted Platform Module, which is not a terribly useful descriptive name. It's basically a bit of hardware on your computer that can do things like encrypting, decrypting, and storing small amounts of data, but it also looks at your machine and tries to understand what state various bits of it are in. And it can use those states to make decisions about whether or not it should decrypt the data that you're asking it for.
Are the states things like, has the computer been taken apart and is it currently in a laboratory in some foreign actor or something, or is it simpler than that?
Not necessarily that specific, but that sort of thing. It tries to essentially tell if someone has tampered with the known state of the computer, like have they turned secure boot off, or has the bootloader changed, has the firmware been changed, things like that. And there's other things that the operating system can hook into, I think, as well. Now, the reason that I got interested in this is because I use full disk encryption on my work laptop, and I find it a bit of a pain when I have to reboot. For example, recently Ubuntu started requiring you to reboot to install some software updates. And the workflow for that became reboot, enter your decryption password, let it run the updater, and then it reboots again, and then you have to enter your encryption password again, and then it boots back into your system. And that was a right pain. Having to do that, and other times that I might, I haven't actually taken my laptop anywhere, so I'm not worried about anyone. I've not left its side, so it's not like it's someone else trying to do anything. It's just me pressing reboot from my logged in system, and it would be nice if I didn't always have to enter the encryption password. So I got wondering whether using the TPM might be a way around this. So I found some useful and some less useful guides to this on the internet. One went into quite a bit of detail about how to set up a script that ran at boot and ran some commands against the TPM and got it to give you the encryption key, which all seemed to run okay, except that it didn't actually get an encryption key out for some reason. When I ran the commands in a logged in system, it worked. And when it tried to do it at boot, it just didn't get anything. So I was obviously doing something wrong there. And then I found another tool called systemd with TPM2, which completely bricked my system. I should say I was doing this on a VM, so that's fine. In fact, I was using QuickEmu with the TPM equals on option to test this out because I didn't want to actually be doing this on a real system. But while I was doing this, I ended up reading some man pages, as you do, and found in the man page for crypt tab that you can configure crypt tab to point to your TPM directly without any additional tools or utilities or scripts that you have to write yourself.
And I imagine crypt tab is something that works alongside fs tab to say these file systems are encrypted and
yes.
Here are the strategies to provide decryption keys.
That's exactly what it does, yes. So you have a list of, here are your encrypted devices and here are what they're called, and then one of those names maps to the thing that you're mounting in fs tab. Finding this, I managed to do quite a bit of digging and find that there's a command called systemd-cryptinroll. And what this does is generates a decryption key, adds it to your LUX encrypted volume, because you can have multiple keys associated with a volume, and then it stores that in the TPM and does some other wizardry in the background to connect things up. Then you edit your crypt tab, you add an option there to say which device it is. If you've only got one TPM, you just say auto and it finds it. And then you rebuild your init RAM FS, which is the system that runs at boot to bootstrap everything. And then that will include the bits it needs to read the stuff out of the TPM. And this was all going very well, except I was trying to do it on Ubuntu. And for some reason, when you try and rebuild init RAM FS on Ubuntu with this option, it doesn't recognize it. And I tried a few different versions with different versions of crypt setup, but it just wasn't having any of it, despite other people saying they were successful doing this on other distributions. So I thought, well, someone said this works on Fedora. I'll give that a go. And I ran exactly the same thing on Fedora, except they use a utility called Draycut or something of that effect to rebuild init RAMFS. And it worked. So I ended up with a system that I could boot into. And when I rebooted, it would decrypt the disk without me having to do anything.
Can I just clarify? You're doing this all in a VM that's talking to the fake TPM module, and you're doing it with Fedora in a VM, right?
In a VM,
right.
Yes.
Okay.
And that's right, isn't it, Martin? It's a software TPM.
Yeah. So what Mark's using here is my QuickEmu project, which is a wrapper around QEMU. And one of the things that I added to that project was to enable a software TPM emulator.
So this was the result I was looking for, except I didn't have the option to, if I shut down the computer completely, have it then ask me for the password when I logged in. So the way that the TPM works is it has a number of things called platform configuration registers, which is basically where it stores like a signature of the various things that it's looking at. And you can tell it when you're running system decrypting role which of the registers it should look at to decide whether it should give up the encryption key. But I went looking at what happens to these registers when you reboot versus when you power down, and there's no difference. So there's no way of saying decrypt it for me when you reboot, but if I do a cold boot, ask me for the password.
Okay, that has clarified. The scary thing that I was thinking is surely it could just unlock like at any point, like when someone steals it out of your bag.
Exactly.
But this, in theory, should work.
So this has kind of got me thinking, what's the actual use case for doing this? Because yes, it would stop the case where someone takes the hard drive out of your computer and then tries to decrypt it, because the encryption key only lives in that TPM. And once they've started messing around with the hardware, it's not going to give it back. They can't boot from a USB drive and get it out. It's not going to accept that. But it doesn't stop the case where, I'm getting off the train and someone steals my bag and then they turn the computer on. It boots, decrypts, and yes, they're at the login screen and they can't actually log in without my password. But unless I'm wrong, my data's not completely secure at that point. It is decrypted or accessible decrypted on the computer somehow. If they could find some other exploit, if there was a bug in the lock screen that meant if they mashed the keyboard a lot, it crashed, something like that.
They don't even need to do that. They could just change the init shell to bin bash. They could decrypt the disk and have it boot straight to the root prompt running bash.
So there is other things which you can do, like locking down grub and locking down your EFI config so that things can't be edited like that.
Oh, okay. Well, the only editing would be at the point when you press F10 or whatever button triggers your grub. Press down arrow, edit the line. And if you can stop them being able to edit the line at boot time,
yes.
I don't know if grub does that.
Right. I'm pretty sure it's possible that you can lock down things like that as well, which would stop them being able to do that. But I still don't feel comfortable with the idea that I've enabled full disk encryption, but whenever you boot the laptop, it just decrypts anyway. So I'm sort of wondering, am I missing something here? Maybe one of our security-minded listeners might be able to enlighten me as to this, or I wondered if one of you two might understand this better than I do. But it seems like an odd setup to me. So I'd be interested to hear anyone's input on this.
So to be clear, you haven't enabled it on your host.
No.
You were fiddling with this entirely in a VM to get it working and understand the technology, but it didn't seem to fit as you want, and so help.
Yes.
Yeah, I can't offer any assistance with this because I've never used TPM for disk encryption. So I have zero experience.
Have you used it for something else?
The only time I used it was when I integrated it into QuickEmu in order to get Windows 11 images to boot. That was the reason that I tampered with it. So it was purely just to satisfy the system requirement for Windows 11. And that is where my TPM knowledge starts and ends.
Linux Matters is part of the Late Night Linux family. If you enjoy the show, please consider supporting us and the rest of the Late Night Linux team using the PayPal or Patreon links at linuxmatters.sh/support. For $5 a month on Patreon, you can enjoy an ad-free feed of our show, or for $10 get access to all the Late Night Linux shows ad-free. You can get in touch with us via email, show@linuxmatters.sh, or chat with other listeners in our Telegram group. All the details are at linuxmatters.sh/contact.
I've migrated to a dual GPU system in 2 of my workstations, so I have Radeon and NVIDIA sitting in my PCs, KISSING.
I do hope they're not touching. That could lead to all kinds of electrical failure.
Well, maybe they're not touching physically, but they're definitely interacting digitally.
So is this, you've got 2 graphics cards with separate outputs plugged in, or are they doing some sort of combined processy, outputty thing to a single screen?
They are not both driving displays. Let me explain. So this all started when I used to have an RTX 3090 in my main workstation. And it's a fantastic GPU, but it has one considerable drawback in that it has 24 gigabytes of video memory, and half of that video memory is on the rear of the card, and the heat that memory creates is dissipated by a metal backplate. And that metal backplate was 99 degrees Celsius at all times.
Wow.
And that backplate is also adjacent to the fan in the case that pushes air out of the case. But what it's actually doing is it's blowing superheated air at the radiator for the CPU water cooling, and it was turning that water radiator into a space heater. And the direction of air that is exhaust from the case was at me. So what that meant is that I was permanently being blasted with not just warm, but considerably hot air. And during the summer months, that was just intolerable. So as much as I like the GPU, I thought I've got to find a better way of doing things. And amazingly, using 2 GPUs is actually the solution. So what I've done is I took the 3090 out, which is an over triple slot card. So it takes up like half of the available space in the physically it's huge. So I took that out and I replaced that with a Radeon RX 6700 XT, which is a dual slot card. And it's what you'd call a mid-range GPU, I imagine. And then with the space that made in the case, I was able to reorder the other cards on the motherboard and free up a single slot space on the motherboard. And in there, I added an NVIDIA T1000 GPU. And these are rather dinky. In fact, it's a single slot GPU and it only takes power from the bus, which means technically it can only pull 75 watts. That's the maximum that the PCI slot can deliver. And actually the card uses way, way less than that. So by doing this, the RX 3090 at idle would use about 40 watts of power, which is not too bad for a GPU, but under load, it would get up to like 365 watts. It's an absolute power pig, in that regard. But it doesn't matter whether it's idle or going full bore. That backplate is 99 degrees all the time. That was the main problem.
Was it not possible to just turn the case 90 degrees and face the other way and blow the hot air out the door or something? It had to go.
When it did have to go, it didn't really matter that it was blowing it at me. That heat had to go into this room in some way or other.
It would find you, yes.
Using the Radeon 6700 alongside the NVIDIA T1000 has brought the power consumption down considerably. The two together under idle conditions, the Radeon uses about 30 watts of power when it's just moving the desktop around. And as best as I can tell, the NVIDIA T1000 uses between 4 to 5 watts when idle because it's really not doing anything. I only have the displays plugged into the Radeon GPU. This NVIDIA GPU is purely for compute, and I'll get to how I use it in just a moment. And when the system is under load, let's imagine I am game streaming, so playing games and streaming that all with OBS. The Radeon is using about 190 watts to basically composite OBS and play the game. And then the NVIDIA GPU is just being used for the compute to do the encoding of the video stream that gets sent to Twitch or wherever.
I've seen other people suggest having 2 GPUs. And in fact, I've seen some people online who profess to be expert at OBS suggesting that this was actually not a good thing and you should absolutely not put 2 GPUs in a machine, but you should just throw one big GPU at it. And so it's interesting to hear your experience of it being good and performant and not hot.
Yes, so it works very well in as much that now I'm getting considerable power savings. So under load, this new configuration is using about 150 watts less than the 3090, and the temperatures are way down. Both those GPUs sit around 50 to 60 degrees depending on the load that they're under, so it isn't generating that same volume of heat into the case and the room around me.
And are there any complications with installing I assume that you're using the vendor supplied drivers for both of these, or are you using the open source drivers for AMD? And yeah, what's it like having both of those installed and managing that?
That's an excellent question, because that's actually sort of the secret sauce in making this all work, and kind of goes to Alan's point about like people recommend not doing this. I imagine maybe those people aren't running Linux where Linux kind of shines at this particular sort of use case. So I'm just using the regular drivers to run the Radeon stuff. So I don't use the AMD GPU Pro drivers or whatever they're called. I'm just using the open source drivers plus the firmware that you get with the Linux firmware bundle. And that means that, Wayland and all of that stuff works, including video acceleration, hardware encoding and what have you is available on the Radeon GPU, but I'm choosing not to use it. On the NVIDIA side, just using the NVIDIA proprietary drivers. But the important step here is on Ubuntu, there's a meta package for the NVIDIA drivers, which has -headless in the name. Mm-hmm. And effectively, that includes all of the NVIDIA drivers except the display server drivers. So no Xorg drivers. And so that enables things like CUDA and NVENC and all the compute capabilities, but it has no facility to drive displays at all.
Right.
So when you run those two side by side, you now get the full compute capability of an NVIDIA GPU, but none of the display output. And that's also what helps keep the power draw of that NVIDIA GPU down, because actually driving the displays is what actually pumps a load of voltage through the GPU in order to drive those displays. And I was talking about temperatures and power consumption earlier. I'm able to measure that with NVTop. So there's a little command line love for you here. NVTop's been around for ages. The NV is a clue that it was an NVIDIA tool, but it recently added support for multi-GPUs. So when I run NVTop now, it's a stacked display and I can see all of the metrics for both GPUs, what's running on them and all the rest of it. So with this configured, and I've run this configuration on Ubuntu and I'm now running it on NixOS. On NixOS, it's a slightly different configuration in that you just tell your NixOS configuration that you're using what's called reverse sync. Because traditionally, when you have an NVIDIA GPU, it wants to be the primary and the other things its subordinates. And what we're doing is we're tipping that on its head. I want the Radeon GPU to be the primary, and I just want the NVIDIA GPU to be the sibling, the dumb thing that we just do compute with. And it works as well on both. It's been really stable. I've been running this for like 9 months now. It's been really great. But this means I have all the benefits of running a Radeon driver on the desktop. So Wayland, if you care about those things, will work just fine. But most importantly, all of those workloads where an NVIDIA GPU is required, for example, DaVinci Resolve will work even though the display driver is using Radeon and it has a requirement for CUDA. It finds the CUDA being satisfied by this other GPU, which means you can do your effects composition on the NVIDIA GPU and the video encoding on the NVIDIA GPU all seamlessly. And the same is true on OBS Studio. everything's composited with the Radeon, but then the NVIDIA GPU is used for all of the hardware encoding, but you can turn all of the quality settings up to 11 on the NVIDIA GPU because all it's doing is that encoding piece. So you get no penalty of your game performance, where the NVIDIA GPU can sometimes take too much when it's doing the video encoding away from the game.
It's interesting. I have a not quite as complicated, but similar setup of multi-GPUs in the NUC that is on my desk here, which has an inbuilt Intel CPU, an AMD GPU, and externally an eGPU, which is an NVIDIA card. But I'm using them the other way around, the traditional way. The NVIDIA is driving the displays and the AMD is for whatever else I can use it for. But yeah, it's interesting that you can actually use both the GPUs at the same time with both drivers loaded, and it works fine on Linux and on Windows.
Right. So you've used it with Windows and Linux quite happily.
Yeah.
I mean, maybe some people haven't experimented with this in other parts of the world because they live in places where air conditioning is ubiquitous and they wouldn't run into this particular, climate issue.
Or they live in Norway where it's just naturally cold. Yeah.
Exactly. And I also have an Intel Arc GPU. And what I'm going to be looking at next is how I can potentially use the Intel Arc GPU in a similar configuration. So maybe use Intel Arc as the primary with NVIDIA alongside it. Or maybe, in my test workstation, all 3 GPUs at the same time and see what madness we can cook up there. But yeah, it's been a great configuration. So if you have got mixed workloads, dual GPU setups on Linux work a treat. And these T-series cards from NVIDIA, single slot, bus powered, not tons of CUDA performance, something around the sort of 1050 Ti sort of region. But in terms of their video encoding performance, exactly the same as a 3090. So pretty great.
I have a further update to what I talked about in episode 10. And a small reminder is that last time I downloaded some historical EV data, charging data from BMW, the manufacturer of the car. And I uploaded it to Axiom, my employer, to build a dashboard so I could see some detail about the different types of places where I've charged and how frequently I use my home charger and other chargers. So that's what I talked about in the last episode. Go back for a refresher to listen to episode 10 for that. But the problem with that is I only had the historical data, and I've had the car for 18 months, and I could download a snapshot of that 18 months. But I couldn't use that to get ongoing data because I'm still own the car and I'm still charging the car, every day or so. And so I wanted to get ongoing data. And BMW has an API for getting that car data. And I tried to register. They have a service called AOS, which is After Sales Online System. And I got rejected. I applied for access and they said 9. So I said, please, it's my car and I would like access to the data about my car. And I got redirected to another department who also said no because, and I quote, I do not fit to be a publisher of technical information. So what I think it is it's designed for app developers or people who work in the automotive industry who want to integrate with the car system in some way. And I kind of moaned a little bit on Mastodon. And then I did a bit of Googling and actually found a tool that helped me. And it's called Bimmer Connect. Bimmer being the colloquial name for BMW manufactured motor vehicles. I went down a little bit of a rabbit warren. In the UK, we tend to call them Beamers, but actually Beamer is generally the term for the motorcycles made by BMW, and Bimmer is the term for the cars, apparently. And there's a different name they use in China that sounds very much like Boma, which sounds a bit like a cow or something. It's very strange. Anyway, there's a whole article on the BMW's website about Bimmer, Beamer, and so on. Anyway, there's this piece of software called Bimmer Connected, and it's open source, and it's a library to query the status of your BMW or your Mini using the Connected Drive portal. And the Connected Drive portal is a thing that I have a sign-on for because it's the thing that the official app uses to link you as a person to your car. And this thing is a Python library, So you could use it to query the API using your existing username and password that you already have, and the VIN of your car, the VIN being the vehicle identification number or VIN number. And it also has a command line tool you can use to get the data. And the command line tool is called Bimmer Connected. And all you do is run Bimmer Connected and you pass it your username and password and the region that you're in, because I think they've got multiple endpoints for USA, China, and rest of the world. And then it produces a JSON dump of data about the car. And what data about the car, you ask?
Well, but this is different kind of data, because before you did like a data checkout, it was all of your data for all time. So
yeah,
what is this? Is this everything again, or is this something else?
No, this is just a snapshot. And the snapshot is like real time. So if you query it multiple times over a period of time, the data will change. Mm-hmm. Well, some of the data will change. There's some of it which is stuff that doesn't change, physical attributes of the car, like the make and the model, the drivetrain, whatever enabled capabilities that the car has, like electric windows and so on. And there's some stuff that doesn't change very often, like software versions. That's reported in there as well. It's just one big JSON file. What else is in there? The charge schedule. So if you set it to charge at certain times, that's in there. The status of the doors and the windows and the sunroof, whether they're closed or open, which is good from a security point of view. But the stuff I actually wanted is also in there. And the stuff I wanted was the mileage, the charge level, the range, and the latitude, longitude, and heading of the car. So I can tell where it is, what the charge level is, and how many miles I've done.
And which way it's pointing.
And which way it's pointing, yes, which is very helpful. I think the reason why they put that in there is in the app, it shows a little picture of your car, and it actually does show it which way the car is pointing on a map, which is, quite cute. I don't know why that's useful, but it is. So I wrote a 5-line shell script, which calls Bimmer Connected with all my credentials, which dumps out the JSON, and then I just throw that at Axiom using curl, using our API. And I do that. I was doing it every minute, but then realized that was a little bit excessive to keep poking it, going, where's my car? Where's my car? Where's my car? Every 60 seconds, especially given when I looked at the data, I zoomed in on the dashboard that I built in Axiom, and I could see that even if I poke the API every 60 seconds, it only actually updates every 5 minutes. So I think my car only reports status every 5 minutes. And so I dialed back my script so that it goes to sleep for 5 minutes and then pokes the API again. And so now I have the historical data and I have ongoing data showing charge level. It doesn't quite have all the information that I could get from the data dump. It doesn't have like the street address of the charger where it's currently sat, but it does have latitude and longitude. And I can calculate if the car was at a certain spot and the amount of charge went up, then I could log that somehow. So I can use this information. It's just not quite as nicely formatted. But I could also once a month do a takeout and get that historical data again. And I'll put all of this in a follow-up blog post to the last one, and that one will be in the show notes. But I just thought I'd mention that I've managed to wrap this whole thing together with the takeout and Bimmer Connected. And thank you to all the wonderful people who've written and maintained that Bimmer Connected bit of Python.
Well, open source will find a way.
Yeah, certainly does. As will a dodgy shell script running on a server in my house.